So this is module number 2. That's what we'll be looking at today. And to guide us is our Excel sheet called LCC. LCC simply means life cycle costing and estimation. So it's one Excel sheet that I've included estimation for concrete and estimation for other things. Now, for you to be a good engineer, you must have knowledge of how to carry out some costing. Basically, in any construction projects, building projects, housing projects, road projects, the concrete element takes almost 60 to 70% of the work. Yes, sometimes 50, but I don't see it going below 50. If you are building a road now, I can tell you if the road have 2 side drains, the cost of asphalting and the cost of good drain is almost 50-50. I know sometimes it revolves around 60-40, but if you must do a good drain on 2 sides of the road, your drain will take almost 50% of your work. If you are building a house, especially a big structure, the concrete element, when I mean concrete element, I'm talking about reinforced concrete anyway, which means it has steel and it has to be held by a formwork. It takes almost 60-70%. So it's important that as a cost estimator, you first of all know how to handle these 3 recurring components in every construction setup. Those elements are concrete, reinforcement, and formwork. Others can be block work. That one I'll just show you how to do it. Plastering. You can say flooring, yeah, whatever. They are all area members. I mean, you calculate the area, multiply by the unit, you get the answer. You can say tiles, and so on and so forth. For instance, why we not talk about this last 4 is because when it comes to block work, for instance, block work is simply 1 square meter is equal to 10 blocks. Yeah, 1 square meter equal to 10 blocks. And the rates in the market now cannot be less than 4,000 per square meter. Because at the end of the day, our aim is for you to cost the projects. So 1 square meter is what do you call it? So assuming I now have a floor plan. So we've not started what we are doing, but let me tell you why we're not going to do that 5, because they are so simple and it's not what we are. But the concrete, the formwork, and the reinforcement is a problem for many engineers. No matter how old you've been in the engineering profession, you must be trained somehow for you to be able to estimate it appropriately. There must be some element of training beyond the 4 walls of schooling, which has to bear on your experience too. So let's assume that somebody gave me this now, 5 meters, 3 meters. We'll be using this for what we'll be doing today. This 5 meter by 3 meter. So what I'll simply do to estimate the number of blocks that will do the work is simply to take the perimeter. So the perimeter is now 5 plus 3, of course, either times 2 or plus 3 plus 5. So the perimeter of this is now 16 meters. And so if the height of this wall is about 3 meters, it means the surface area is now 3 times 16. And that will give me 48 square meters. So since I say 10 blocks is 1 square meter, it means I need 480 blocks to do this work. Okay, or I'll simply go to my BEME and said under the column for cost, okay, I will say the cost is 4,000, and then I'll get the cost of doing it. So it depends on what I want. And of course, somebody will now ask, how do I get to this 4,000 per square meter? Well, that's the prevailing rate in the market. But if you really That's why I said you need element of experience to do estimation. Believe me, there's element of experience. Gina Montari, I'll shortly call you. How they got about this 4,000 is simply cost of block, for instance, is about 250. I don't know how much it is, 250, 300. Then labor. I think masons collect about 15 naira or 17 naira, but let's say 15 naira. Then materials, you need some block, cement, mortar, and what have you. Let's give it 100 naira. You can do the breakdown. Then my profits. In fact, 4,000 is not working again. It should be 4,500, but let's just go. Let's roll. Profits. My profit per block is, let's say, 15 naira. So, gentlemen, have you seen it? We won't have 450 now. 450. So 450 naira to lay one block is 450 naira. Since we are talking about 1 square meter being 10 blocks, so that translates to 450 times 10. So the rates should be 4,500. For 9 inches block, maybe for 6 inches block, it can be 4,000, because for 6 inches block, that 250 becomes 200. So anybody who is quoting for block now in the market should be quoting something in the range of 5,000 or 4,500. So Engineer Zubairo, what do you want to ask me? Maybe it's something you want to get to let me know. You raise your hand, sir. Hello? Once again, can we all hear me?
Yes, sir.
Yes.
So is there any question on what I just explained now? So I'm not going to talk about plastering, flooring.
Okay, no, it's just an observation.
Okay, for the
I
tiling,
noticed
sorry, before
yesterday you were very clear
for the tiling
session,
sorry.
But today you are cracking. Maybe can you hear me?
Your network is a bit poor.
I hear you.
It's very clear.
Okay, I think you are using earpiece. Yeah, can you remove your earpiece, please?
I'm using nothing.
So,
hello, sir.
It should be your network.
I'm using nothing, sir.
No, we are not hearing you. You are cracking.
Let me pause this thing so that we can talk about it. So, recording. Now, we'll be discussing about concrete. So let's start with concrete. Concrete has 3 elements. Hold on. Concrete has 3 elements. So those 3 elements that makes up concrete is the cement, the fine aggregates, but let's use the local term, sand, then aggregate or stone. Should I use stone or aggregate, stone? Whatever. Yeah, let's use stone. Call me a local man if you want. Then this one, of course, we call this one fine aggregates. Every concrete must have a specification of the strength. That strength is a function of the standard. It must tell you whether it's C15, C10, C15, C20. Now I stand to be corrected because things have been changing. C10 means it has a concrete strength of 10 Newton per millimeter square. Strength is a pressure. Pressure is force over area. Force over area. Force is measured in Newton. Area is measured in millimeter square. So in terms of the small scale, scalability, it becomes Newton per millimeter square. So it's something to say kilonewton per meter square. It's just a function of scale. And what C10 means is that if you are mixing these 3 components, you're going to mix them in the ratio of 1:4:3. 8. Okay? When they say it's C15, they are simply telling you that this strength is higher than 10. And if you have to mix the concrete, you have to mix the concrete, the cement, the sand to the aggregate ratio has to be in the range of 1:3:. Meanwhile, gentlemen, these things are all in BS code. I can share the BS code if I have the soft copy, but it's an open source. Just go online, you get it. If they now say it's the C20, which is the most common one, this is the one you must take cognizance of because that is the basis, that is the standard. C15 is used for mass concrete, for places that we don't require heavy axle, heavy load, heavy point load, heavy shear load, just like normal day thing. C10 is for blinding, to blind things, just like a waste, in quotes. In fact, these days, nobody puts 148. Some people say they have stopped using it, which I agree. But knowing what cement is doing us in Nigeria, we can't rule it out. Okay. Now, C20 is the one I want you to take cognizance of because that's the one that is more prevalent. That is the base. That is it's more like the baseline, like the benchmark for a standard work is 1:4. No, 1:2:4. One is to 2:4. So it simply means one portion, please. There's nothing like bag. I think I've not said bag. This is one portion when I say ratio. So this is ratio. So ratio means any standard you're using in measuring cement. If you're using head pan, that means you also use head pan to measure sand. You also use head pan to measure the stone, the aggregates, sorry. Okay, the fine aggregate and the coarse aggregate. Okay. So this is what it means. Then you can also go on and look at other standards. There is a C25. C25 is now 1:1.5:3. Then there is C30. There is even C35. There is C40. Okay. C30. I stand to be corrected. It's about 1:1:2. Then anything higher than C30 should be done based on what they call laboratory condition. That means you're going to use plasticizers, you're going to use some additives on them. If not, it's almost achievable. Okay? Why? Because in every cement you mix, there is what we call water-cement ratio. That is one of the most determining factors in your mix ratio. The standard says that the ratio of water to cement must not be more than 0.5 to 0.6. So we have what we call water cement ratio. Very, very important. That's why I tell people, when you see concrete that is very workable, fluidy, it does not mean it's the best concrete. Because the more water, the less the strength. The more water you put in concrete, the less the strength. The thicker, the less water, the stronger. But then, the concrete need to be workable. Workability. Workable means you have to pass through formwork. It has to enable you to work it, sort of. So water cement ratio is very important. And water cement ratio, the standard, which we are using, BS standard, whether BS standard or Euro code, says it must be water cement ratio must be, or cement water ratio. If you use water cement, it will be 0.5. Let me come and use one analysis that some of us need to crack our brain to 0.6. If I change this word to mean cement water ratio, watch me now. Okay, no, let me not confuse us with this. So if it becomes
2 to 3.
Cement to water.
2 to 3.
No, sir. You simply add 1. You simply add 1. So it becomes 1.5 to 1.6. Do you know that these two things are the same, gentlemen? Whether you say cement water ratio or you say water cement, it's just like when I asked you to, increase my salary by 50%. You can multiply my current salary by 1.5, or you multiply by 0.5 and now come back and add it to the capital, add it to my default salary. So it's the same thing. This is mathematics, and we're engineers. So what I said, but if you multiply my salary by 1.5, you automatically have increased my salary by 50%. But you can also multiply my salary by 50% by 0.5. You now add it to the 100% of my salary. So whether you are using 1.5 or you're using 0.5, it depends on the terms you are using. Whether you are going from water to cement or you're going from cement to water. So it means if I'm going from cement to water, I am telling you that if you add one portion of cement, you must add half or 60% of water. Does it make sense? Of course it does. So you don't go and add 1 kg, 1 bucket of water, 1 bucket of cement. It doesn't work. That concrete will fail. So this 1.5 to 1.6 becomes the determining factor for the strength for you to be able to achieve the appropriate strength. If you have to add more than this, then you need to add additives, plasticizers, strengtheners, okay, and many other things I don't know their names, but they all exist there. You know, when you come to, when we have them here, come to some foreign countries, you see specialists who are specialists in producing concrete. So if you tell them to produce any kind of concrete, they know how to produce it. And if you go to the lab, it will give you what you want. So this is it. Now, let me take us back to school. Let me take you back to school. In your school, in school days, you know that density is equal to mass over volume. This is very important. Now, this water cement ratio is also why people talk about wet, what they call wet to dry. When I say wet to dry, concrete volume, wet to dry concrete volume is also between 1.5 to 1.6. Gentlemen, let me use this analogy. Very simple analogy, funny, but is real. If you bring gari on a bowl, you want to soak gari. If you weigh that dry gari on your scale, you're going to get 1 kg. If you add 50 kg of water, please, what will be the new weight? 1.5. Yes. So we are mixing constituent of concrete dry. But are you going to cast it dry? No, you're going to add water. So it means that at the end of the day, if I get any quantity in terms of the dryness, if I want to scale it up to wetness, I will multiply by 1.5 or 1.6, depending on the degree of water that added to it. So if you give me dry gari now, and it weighs 1 kg, and I go and pour hot water, what 50 kg in it, depending on the density of each element, I'm going to get a new density. And that density most likely will revolve around 1.5 because I added 50 kg of water. The only difference is that because the density of the dry gari is not up to, it's not as expected. Are you with me? Any question? Any question on this?
Yes.
Please ask your question. Ask your question. We're in the class. Are you part of the class? Okay. Please, can you ask your question, please?
Hello, excuse me. My question is this.
I'm hearing you, sir.
This water, wet, dry density you are talking about, of what significance is this to the strength
of what?
Significance.
Well, the significance is that you must maintain your concrete to be workable, to be what we call slump. There's this slump test we do.
Yes.
If you, okay, let me give you one funny example. If you do PAP, the local PAP we do, there's a level you put water, the thing becomes nonsense.
Yes.
Okay, so just use that. So your concrete should not be too watery. So to guide you, you should be within the ratio should be not more than 1.5 to 1. Now it's a range because in engineering we talk about approximation. We don't talk about specific. We're not specific. We're not specific in engineering. We give you range. So this range is simply depend on whether you're using for a column or you're using for beam. If you're mixing concrete for beam, it doesn't have to be too watery. If you're using concrete for column and you're using steel formwork, you have to make it, you can tolerate some level of water. So that range is to give you flexibility as an engineer. The significance is that if I mix 1 kg of concrete dry, if I convert it to wet, the value will increase by 1.5. That's just the significance.
Okay.
Are you okay now, sir?
Yes, yes.
Okay, so let's move now. So now, the next thing you do, so now we are looking for mass. Our target is to get the mass. Our target is to get the what? The mass. Okay, and mass of what? Mass of sand, mass of stone, mass of aggregates. That's our goal. So from this formula for density, the density of these elements are in the open domain, is available online. We know the density of cement, we know the density of sand, we know the density of stone. We don't have problem. For the volume, we know what we want to produce. Our volume here is 1 meter cube. So our volume is fixed. Our volume is fixed. Even if you ask me to get the volume for 100 cubic meter of concrete, my job is to get the volume for one, the value for 1, and then I will scale up. So here, volume is fixed because we are looking at what would give us 1 cubic meter. So if we are casting 10 columns, each 2 cubic meter, we know we're calculating for 10 cubic meter. So for now, volume is fixed. So that boundary condition is fixed and is 1 cubic meter. Okay, I'm writing it this way because they don't have the facility for me to do this. So what I want to do now, I want us to Google the density of these 3 elements. So can you go online? Everyone is online. So I know the answers, but that is part of design, gentlemen. Whenever you are doing design, you must have Google around you. So I want us to go online now in the next 5 minutes. Get me the density of cement, get me the density of sand, get me the density of stone. If you get yours, kindly go to the chat box, type it in and tell me density of cement is this, density of sand is this, density of stone is this. So now we now have our volume, we have our density.
Cement is 1.
No, don't say it, sir. Go to the chat box. It's part of the design methodology. You don't do design without Google because many things are in the open domain. Just like research, nobody does anything new. Look at what others have done and then build on it. So 5 minutes, get me those 3 values. Water is 1. No need for do water. Water, any engineer knows water. So thank you. That's a good one. Because water is 1. Therefore, water dry to wet is now 1 plus the additional distance. I think that's also good. Dry sand, 1,600. I agree with you. Density of sand, 1,450 over 2,000. Good. Njadiko said dry sand 1,600. I'll take Njadiko's own. Why? Because in engineering, you go for worst case scenario. The less the density we get, the more the material, which is good for on the part of the engineer. Good. Just Sanusi said gravel 1,700. He now says cement 3,100. Just Sanusi, it's not the cost, it's the density. Cement is even lighter, it's less dense than sand. So there's no way cement can be 3,100. Cement is like dust, it's like silt, it's very light. So the density is close to 1. The density of stone 1,600, yeah, is about that. Stone is between 1,600 and 1,800. Yes. Yeah, I'm impressed. Okay, let's not waste our time. But I'm just happy that we understand what the plan is. So here we have established the concrete. So density is now cement is 1,440 kilogram per meter cube. Sand is 1,600, same kilogram per whatever. Aggregates, we're going to use 1,800 or 1,750. So if we are now doing for 1 kg, sorry, for 1, so if you make mass subject of the formula, becomes density times volume. So we have density, we have volume, we have mass. So our answer can pop up. Okay? Our answer can pop up. But the volume we have comprises of 3 elements. This volume is equal to the volume of cement plus volume of, that is 1 cubic meter, okay? 1 cubic meter. Of sand plus volume of stone. Okay, so the next thing we now do is to say, what is the ratio? Remember those days we did talk about ratio. What is the ratio of sand, cement, and sand in 1 cubic meter? And with that, we just multiply by density, the mass will pop up. So here, let's use CE25. Let's assume we are producing CE20 concrete. And we say that the mixed ratio, sorry. Okay, we say the mixed ratio for this is 1:2:4. It means that cement, the ratio of cement here will now be 1/7. Yeah, 1/7. You know, I got my 7. This plus this plus this. Okay. And that will give us what? 1 divide 7. 0.43. That is the volume. That is the volume of concrete or cement, sorry, in 1 cubic meter. For sand, it will be 2/7. And that will be what? 0.286. Aggregates, 4/7. (0.571). What can you get from this? If you add up all these three, if you add up this plus this plus this, you get 1, which is 1 cubic meter. Thank you. Which is 1. So we have split 1 cubic meter into their constituent volume. The only thing now you need to add is if you come for each one, the mass become its own density times the volume times the wet dry ratio. You get it. So to do that, let me carry this one up and continue anyway. So here, for cement, it will now be mass, cement mass. Remember, we say mass is density. What is density of cement again? 1440 multiply by the volume. And what is the volume now? 0.143. Then because this is wet mass, but we need the dry mass. This is dry mass, sorry, but we need the wet mass. We'll now multiply this value by either 1.5 or 1.6.
0.6.
But for the purpose of balance, we'll multiply by 1.55, which is like average, okay? So can we do that? It will give us
319.18.
319.2 kg, because every other person is on kg. So to produce 1 cubic meter of cubic meter of C20 ratio 1:2:4 concrete, you need 319 kilograms of cement. Now you see why people get their 6 bags. If you divide this thing by 50, you know, by 48 or 50, let's say 50, because bags of cement comes in 50 kgs. So if you divide this now by 50 kg, you now see where people get their 3.5 bags. It's giving me 6.38. This is where you now see people telling you that it requires 6 bags of cement to produce 1 blah, blah, blah. But now you have known how to get it, and that's cool. So it's giving me 6.4 bags of cement, but I'm not dealing in bags because I'm not an artisan. I'm not a layman. I'm an engineer. So I'll put it there. because in other countries they don't have Dangote, they don't bag their cement, they bag their cement in bags. So you need to know the standard, and the standard is in what the weight, the mass, how many kilogram. That's how you don't an engineer don't come and say bags. Yes, you can convert to kilogram anyway, but you must speak it the way it is. So the next thing is sand mass. Sand mass becomes density over volume. That is our defining formula. Mass is equal to density over volume, which is a universal known formula for whatever you want to do. So now the density for sand is 1/600, which makes sense. Sand and cement are almost light. Sand is just heavier than cement slightly. Multiply by its own constituent ratio, 0.286. Then multiply by the dry to wet ratio. This is so important because we are dealing on dry to wet ratio.
1.55.
1.55, which is what we've chosen on our own. But if you're a good engineer, you choose 1.5, meaning that your concrete will be top notch. Except if you need to add more water, which will not exceed 1.6, so that to make it flowability, there's workability and there's flowability of concrete, especially if you have very complex formworks. So let's calculate that, 0.286. Then multiply by 1.55.
709.
So you need
3.
You need 709. I'm gonna leave that point. Kilogram of sand, or 0.7 tons. Yes, because they will tell you tons. Okay, the next guy is aggregates. For the aggregates, which is the big man, this is the big man in the house. The density is 1,750. Now, some aggregates are up to 2 kg, 2 in 2000. In fact, some aggregates are 2.3, but those are those old aggregates we used to see in the east and in the Niger Delta. I don't know where they get in the north, but those ones are very dense, those white stones. But as per all these crushed stones, please just use 1,750. In fact, some might even be lighter. Some that are quasi can be even be 1.7. Okay. Of course, we know that not every stone stones have different weights. Good. But at least this is the one we know that is more common. So 1,750 multiplied by its own shear ratio, which is 0.5. That means for every concrete you are casting, aggregate constitutes almost half of it. It's almost half of it. Yeah. Multiply by the same ratio. And that will be 1,750 multiplied by 0.571 multiplied by 1.55. And it's giving us 1,548 kilogram, or 1.5 tons. So with this now, if I am to produce that floor plan we had, remember that our floor plan is about 5 by 3, right? Yeah, that floor plan is about 5 by 3. Here was about 3, and here was about 5. Okay, so if it's a slab, it means we are designing for 15 square meters. No, sorry, pardon me. The area is 15 square meters. So if the thickness D, small d, is the usual 150 mm. Let me clean this, gentlemen. Wait, let me clean this. So if the concrete, if the floor, so the volume now, sorry, the volume of this slab now is now
2.25.
God bless you. By 5, 3 by 5 by 0.15, which will give you 2.25 cubic. Cube mech. Is that how they put it? Cube.mech. Yeah, something like that. So it means I will now multiply each of these elements by 2.25. So if I come to the cement now, I will now say, don't worry, we're going to Excel to do this. I will now say 2.25 times 319, right? Sand will now be what? 0.7 ton times 2.25. And aggregates. $1.5 times 2.25.
Hello, sir.
Yeah, I can hear you.
For cemetery, why can't we assume the cement as 0.3? Because all other ones are in tons.
You're right, sir. Yeah, it's same thing. Yeah.
Question, sir.
Yes.
Please, sir, how do we come about 2.25? I didn't really follow.
Okay, this is a slab. This slab is 3 meter by 5 meter, and the thickness is 150 mm.
Okay.
So volume is length times height times depth, isn't it?
Yes.
So you answer the question.
Okay, sir.
Are you with me? Now we're talking about 2.25. You know, when you calculate your elements in your building, the column, the slab, the beam, you might get something like 150 cubic meter, 180 cubic meter. You just come and multiply them by that, and you get it. You get the volume at a glance. $1.5. So this is tonnage I need. And then this one is 717.8 divided by 50. 14 bags. 14 bags.
0.7.
Okay.
No, it's correct. It's
I'm getting 14.3 bags. Any question?
Yes, I have a question.
Okay.
When we're dealing with reinforced concrete,
Yeah.
do we consider the reinforcement when calculating?
God bless you. We are coming to that. That's very wonderful. Okay. Let me give you an example. You see, concrete now, concrete is about 50,000-60,000 per cubic meter, depending on the grade. But reinforced concrete is about 80,000-90,000. So the other one now comes as a concrete, and that is the cool thing about this class, because I'm going to show you nominal design. How, once you get the volume of your concrete, you can automatically deduce the volume of the kg of reinforcement. You don't need to go and start doing bar bending schedule, though that is the normal thing to do. But believe me, I have done it severally. You and the person who wastes 1 week, 2 weeks doing a bar bending schedule will come to the same answer. If you are very experienced, see, forget it. In engineering, experience counts. BS code says that the nominal design is that for every 1 cubic meter of concrete, you need a minimum of 100 kilograms of reinforcement. or for every 10 cubic meter of concrete, you need 1 ton. Well, that's the next session, so don't preempt me. So now, we have done this, but this is not enough. This is not enough because in our world of today, everything you do as an engineer must be domiciled in Excel. You must know how to use Excel because you got to see, because last month I produced this, most of you must have seen it on the social media, yeah, where I produced a template of the current cost of concrete. Why did I do it? I had a job with one of the river basins, and I was asked, and what they used was 40,000 for concrete. 40, or sometimes somewhere they use 50. They use 40 for non-essential elements, and for the serious element they use 50,000. Now they did this thing when cement was 2,500, meaning that 6 bags now.
Sorry, bags, are you saying 50,000 naira?
Yeah, per cubic meter of concrete.
Wow, that's
you mean it's high? You mean it's
very
high?
Very low. It's very low.
Yes, now that's what that's the story. That was what made me to come to incorporate this thing in my training. I found out a lot of people don't, even those people who do those bills. Believe me, I'm not believing anybody, but some government workers just have to work on themselves. The capacity is so low that they assume rate. If you ask an engineer to go and do rate, he will just pick up a rate of 2010, and he will just lift something and just put it there. But if you understand this, if you have come for this training and you understand this, for instance, we say 6 bags for C20. Please, how much is 6 bags in the market? Is it not 30,000? In Abuja, yes, last week they announced that from 1st of April, 1 ton of aggregate is now 6.5. 6.5 is not the landing cost, factory cost. Landing cost is going to be around 8,000. So for 1 ton, it means I have to multiply, or 10,000 self landing cost might be, Abuja will be 8,000. Okay, then Niger Delta will be, you know, Sanusi, what would it be Niger Delta? You must have done a work there.
Hello.
Yes.
I don't have the current price anyway.
Is that Sanusi Diko?
Yes.
You're not serious. You know where you know where 1 truck is 250,000, sir. 10 years ago, when it was 60,000 in Abuja, it was 230 in Bayelsa. So by the time and this is 20 tons. So by the time you do the division, you will find out that if you are quoting 50,000, 60,000 in Abuja, then Niger Delta, you should be quoting like 75,000. But we're going to see that. And the only thing that will help us to get that is Excel, because with Excel, all this thing we're doing, if tomorrow they just come and tell me that something has changed, or say we're no longer doing C20, we're doing C25, I'll simply go to my Excel and just change my 7 to 8 or to 9 or to 2 or whatever it is. So at this point, let us go to our Excel.
Please, so sir, before we go to Excel, sir.
Yeah.
We didn't consider the volume of water required for 1 cubic meter of. Is it possible for us to calculate the volume of water required, as in to have an idea of the volume of water that would require for the 3x5 meter floor?
Okay. You mean as per cost? You mean in building the rates?
Yes, in building the rates. As in,
no, we've not built rates. We've not built rates. That's what we're going to do in Excel. If I'm building rate, I'll include that. I include my profits.
But we need to know the volume of water, the total volume of water for any project. How do we calculate that?
Oh, I think she's talking about the quantity of the volume, the quantity of required for a cubic meter.
Water required. Yes.
Just like you have an idea of what you have, all these sand, cement, aggregates. So, can we have an idea? Is there a way we can have an idea of how we can get for a cubic meter of concrete the volume of water required?
We use the water cement ratio.
No, I know it has been factored in, but in nominal terms, how can you get the quantity?
I use water cement ratio now. Water cement ratio. There's a ratio between water and cement.
Okay.
Water cement ratio. There's a value 0.5 to 0.6. So if you know the weight of our cement, then we can calculate the weight of our water.
Okay.
I think what she was trying to find out, the water has been considered. That factors we have already considered, but I think what she's asking the actual volume. That's what she's saying. So, and which you did not show the actual volume.
The volume in liters.
Yes,
the
in
volume
liters,
in
not
liters.
gallons. I understand you.
Yeah,
Let
okay.
him come back. I think
I'm
it's
back.
up.
Thank you. So at this point, gentlemen and ladies, can we move to the Excel? Because I said that everything you are doing now must be Excel based. So in Excel, we define the grade as C20. And in terms of the design, in terms of the mixed design, which is called mixed design. In terms of the mixed design, it is 1:2:4. If you try writing this thing and it's not going, you simply right click and go to format cell. Under format cell, you make sure that the cell is formatted as a text. If not, you cannot write 1:2:4. It's not possible. If you do not go to the format, if you didn't right click on it and say, treat whatever is inside that cell as a text. Okay, so the total is 7. Hold on. Is everybody on the same page? Do you have the Excel? Have you opened it?
Yes.
Now, here is 7. So our dry wet ratio, I'm using 1.5. You can change it anytime. We said that 1 bag of cement, we reminded ourselves 1 bag of cement is 50 kg. And 1 ton is 100 kg. And we said the amount of water we need is 50%. That is why we got 1.5. And that translates to 50% means 50 kg of water. That's what we need. Gentlemen, 50 kg of water simply means 2 buckets of this white paint that the people that the concrete casters use. Okay, take notes. And that reminds me, also know how to use local parameters. Know how to use local parameters, local measurement tools. If they're using cement buckets, 1 bag of cement will give you 2 cement buckets. Take notes. But if you're using those old head pan, it will give you 2.5. So at the moment, treat 1 bag of cement as 2 buckets. So that when they are bringing 2 buckets, you know they're going to bring you 4 buckets of sand and then 8 buckets of stone to give you 1, 2, 4. 2 buckets of cement, which they will open. They will do it half-half. You know how they do it. What confuses people sometimes is that when these guys look at how coarse your aggregate is, okay, instead of them giving you cement, instead of them giving you 4 buckets of sand, they will now give you 5 and now give you 7 of stone. Gentlemen, is it not the same thing? It is. And let me tell you something, don't even claim to be an engineer. Sometimes do physical observation. You find out that, like in Abuja here, we have different types of stones. There's one they bring from Kaduna River. The sand is as good as a stone. It's so coarse. Then there's another one they bring, which is close to plaster sand. It's so fine. So, mixed ratio, you are supposed to mix your aggregates, at least two types of aggregates, but nobody has that time. So sometimes these guys have a way of balancing this. So sometimes they will even give you 6 sand and 6 stone. You'll be wondering, what kind of mixed ratio is this? Please don't be confused. This is 1:4. Okay, all they are trying to achieve is that based on your formwork, based on the level of finishing that you want, and based on the quality of the fine sand, or maybe it's a 3/4 aggregate. So when they look at it, they find out that it's not workable. If you pour it on slab, there will be a lot of honeycombs. It will not look good to the eye. So what they do is they take from Peter to rock pour, but at the same time, the strength, the robustness, and the workability and the flowability of the concrete will still be top notch. So I want us to take note of that, because sometimes when they say that, okay, we're using sea stone, sea sand, you say, no, it must be forced sand. No, you make a scale observation. Well, this is a different class. Okay. This is not, this we are in cost class, so that will be for civil engineering class. Now, we will now come here. I'm just teaching you how I build this template so that you can also leverage on it. So I put 1 here, which is, this means for the cement, for the ratio of 1:3:4, cement is 1 portion, sand is 2, aggregates is 4. So I put it that way because when you are using Excel, it's good that you do cell operations. Make sure you don't write anything. Just make sure that everything is written in the cell. Don't type in anything. I think I discussed that yesterday. So here, from our Google, we got cement density as 1.440. We got sand as 1.6000. And we got this as, I can change it to 1750 just to be what we got. You can see that my value have changed. And that's the beautiful thing. So this ratio, let me format this to 3 decimal place. So I right click on it, format cell, numbers, 3 decimal place. Good. So what volume are we looking for? 1 volume, 1 cubic meter. So I will now come here, dry mass. So what's the dry mass? Equal to density is equal to mass. Mass is density. I'm gonna have problem now. I'm gonna have problem. Okay, I've got it in it. Times the ratio times volume. Let me start with volume. Times volume. But I also have to times with the ratio because the volume is not 1 here. The volume of cement in particular is not 1. The volume is 1 times its own ratio. Then times the factor of safety or the wet-dry conversion ratio. 309. I'll do same. But if a sharp guy that knows how to use Excel, let me see whether Excel can do this for me. But it doesn't do it for me. So what I'll do is, when you come here, listen to me, see what I'll do. If I come here, I want this to be fixed, 1.5, and that is C4. C4. So I'll go to C4 and I'll put the $sign. I'll go to the column. Before C, I'll put the $sign. I'll go to the column, I'll put the $sign. It will fix it. So if I come down here, I can drag down to give me the right answer because I fixed it. So this is fixing Excel. This is for another class. I just say, let me just show it to us. So what it means is that when I drag down, Excel will automatically understand that when it comes here, it doesn't need to move right, it doesn't need to move left, it automatically fixes this guy. But if not, I'll simply come here and just start to do the same thing again, which is, I don't know, which makes me a non-professional, a non-Excel professional that I claim to be.
Why he fits this? Why he fits this?
The same thing. So, but I won't do that. I'll act like a professional. I'll fix that cell and push it down. Okay? No, sorry. This is, I've done what I'm supposed to do. This is for wet. So for dry, I think I need to eliminate this. This is dry mass.
Oh.
Yeah, I'm just doing 2 stage, okay? Stay with me. Stay with me. So for the wet, I will simply multiply this by
It's 50.
1.5.
1.5. Yeah.
Yes. For me, I'd like to fix it. I'll come here and fix it. Dollar row, dollar column. So I'm fixing it on both sides, on X and Y. It's not going to move. Because Excel has this artificial intelligence that when you are doing some things, it will assume that you want to go down. So the next one, if I had dragged down without fixing, it will assume 50 for the next one, assume 1,000 for the next one. Whereas that's not what I want. And that's why I had to fix it. So for the bags, I'll simply say this one, whatever that is here, divide by 50 kg.
That's 57.
I didn't fix. I didn't fix. I didn't formula. I didn't put in formula. I'll put in formula. 50. Are you with me? I'll fix it.
Yeah.
55.
Right, he's right.
For the other side, tonnage.
Wait. Can somebody probe this? I need to be sure.
What are in tons?
These ones are
They're
in
not in
tons.
bags.
So to be
Stand and
by
aggregate are in tons.
1,000.
Yeah, you can't
Whoa.
fix it, though.
I can't fix it though.
Yes.
The
Okay.
units are different.
No. This one will be over 1,000.
Yes.
I cannot fix it now for the last two, right?
Yes.
And I'm just doing this for us
That's
to
already
just
done it. I was telling you how
ourselves.
to arrive at those formulas. He's teaching you another thing that is supposed to even not to show.
So here will now be 2.25, yeah, not 3, right? The size of our slab.
Right. Yeah, right.
Which one? Cement. 2.25.
So for the cement, it will now be C17 multiplied by H12. Okay, H12 is our bag of cement. Am I right?
Hello, sir.
Don't type anything. So
Hello,
instead of me
sir.
typing bags, I deliberately say equal to, and when I went and click back. Please, I want you to learn this habit. It's cool. Yeah, I can hear you, sir.
Sir, what is that 4 meter doing?
It's doing nothing, sir. It's 3 now. It's 3 now. It's 3 now. That's 3 by 5. Center, where is center?
Who is this?
Are we done?
Who is that?
Now, if you look at here, you see a different values. This different value you saw here is factor of safety. I don't know how to put it now. Extra, I call it for waste. Though I'm wrong, it's not up to 10%. So I now multiply, I now come and say, I put this as factor of safety. This is extra pass of safety for waste. You know, it's supposed to be 1.05. But I say 10%. So I now say this multiply 1.1. That's I'm adding this at 10%, you know, to play safe as a contractor.
0.15. Check. I didn't give us this one.
So this is it. So you know why this is just small tonnage, small volume. If it's a big structure, this thing should be like 2,000 cubic meter or 600 cubic meter. I think those days when I used to do construction, there was these days I casted about 400 cubic meter in one day. Yes, yeah, 400 cubic meter in one day. I've once done that, almost a trailer load of cement, but not anymore anyway. So that is that. So any question? I've gone into consultancy for long now. You know, Sanusi?
Sir. What does
I mean? No, we want free money now.
Sorry, question. Is it ideal for us to use a factor of safety of 1.5 for all the elements?
No, that's not factor. This is only me talking about something. 10% is what I'm using. 10% is for me to be safe because I know that
10%
it's will steal one bag of my cement. And those people are bringing concrete. They will tell you it's 20 tons, but it will be 18 tons. So I know that one.
Okay.
That's why I said there's a place of experience for every engineer. Though you need to get into trouble once in a while, then you learn your lesson. I'm in a good mood today. Okay, now let us continue. So now we have done this. So for pricing, to get the cost now. So after doing this now, the next thing is how do we get the cost now? Now, to get the cost now, it depends on location. So let us, and I need to save this thing in a different thing. I don't want to change this template. It's okay. I think let me save it in different. If I finish, I'll say don't make changes. Don't save changes. Okay, so now let's do the rates now. For 1 cubic meter, let's do the rates. What's the price of cement now? 47, right? Yeah. What's the price of cement in your location?
Yes.
Okay.
4547.
Okay, 47.
4550.
What is the price of 1 ton of sand in your area? Simply, how many tons do you buy and how much do you buy it? You divide it. That's all.
We buy
and then
20
you add,
tons.
Sorry?
We buy 20 tons for 65,000.
50 tons. Which motor? Which motor carries 50 tons? On
20 tons.
On Nigerian road.
I said 20.
Okay, 20. Okay, 20 tons. How much do you buy it? How much?
For 55.60.
Wow. Including transportation.
Haulage, yeah.
So 60,000 divided by 60,000.
Where?
Divide 20. Which location, please?
Lagos.
Lagos. Okay. So 3,000. So here it's supposed to be 3,000.
No, I don't think that should be in Ogun State.
Lagos and Ogun State, is there any difference?
Lagos
Yes,
mainland is 85,000 now.
Wow. But let's use a uniform. So let's say 3.5. Okay. 85,000. Yeah, because of transportation, sir. So let's use worst case scenario. I am more comfortable. 20. Oh, I didn't put the quality sign. Yeah, that's Ogun State. 4,250. Then aggregates. Aggregates how much? What do you buy in Lagos?
165 for 20 tons. Hello?
Sorry, let me edit this. 1 minute. This is 148. I can hear you. I'll write it down. Forgive me. Let me put it properly because this is for record purpose. For learning purpose. So Lagos sand is 85,000.
Lagos mainland though.
Let's use the worst case.
Fade
Let's assume
specifically, Fade in Lagos.
let's use the worst case or the average case. Then stone.
They are doing it for us for 190. 190 to Fade.
Divide by
165 to Ifako.
Is it 20? Yeah, is it 120? We might even do range. Might be better to do range.
165 to Ifako.
Don't use just one. This is for demonstration purposes. Use
okay. Is it for 20 kg or 25 kg? This one. The aggregate.
20 tons. 20 tons.
20.
Yeah, 20 because they can't carry 25. It will break their vehicle. Engineer, they will say for demonstration purpose. Can I tell you one thing? Yeah? Yes, 20. Okay, not the China truck. So this is 95. You know, this thing we're doing, I don't want us to take it for granted, okay? Why? Because this is what can help other people. So by the time you build these rates, you guide other people. Because sometimes I publish these things on our various engineering platforms so that people can learn, you know. So here we have, water, 1,000 naira water cannot work again for 1 cubic meter. 500 naira water cannot work. Am I right?
Let's do 1,000.
Yeah, 1,000 naira. So labor. Remember those days, 1 bag is 500 naira, am I right?
Yes.
Hand mix. So placement, this one now is more like placement, assuming you're not buying. So can we say 6,000 naira is enough? Yes.
1 cubic.
To mix 1 cubic, to mix 6 bags.
6 bags. Yeah. Yeah.
It's almost like 1,000 naira.
It's not enough. It's not enough.
1,000 naira per bag.
Yeah, that's
1,000 naira per bag now.
Yes, so that's 6,000 now.
6,000, okay. 6,000 is okay.
Or let's play safe, 7,000.
No, 6,000 is okay.
You say it's for demonstration purpose, so let's keep demonstrating. Okay, what profit do you want to make? What profit do you want to make?
25%.
Inflation is 15%, so we can use 20%.
Okay.
If inflation is 15%, you can use 20%.
Good. That's good.
You can use 25%.
20. So if I use 20, look at it. C 36 times D 34. So that is 10,000 naira. So if you now add 2 of them, which is D 37 plus D 34, it will give you 65,000. So OJ, are you okay now? Does it make sense to you now?
Yeah, it makes sense.
Okay.
But I have a question.
Okay.
I don't know if you are familiar with the standard rates generated by the government.
No.
They're not familiar with it. The Lagos State rate, we have a rate.
Okay, what's the rate?
We have quantities, we have description for each job. It has made it easy for engineers to prepare bills of engineering measurements and evaluation. And they came about the rates doing all of this. So they've made it so easy.
And what's that rate for concrete now? What's the rate for concrete?
The percentage profit. The percentage profit for contractors and direct labor, I'm not so sure of. So that's the basic reason why I want to know how to cost from the basis.
Yeah.
If you understand my point.
So are you okay with this now?
What is the prevailing rate in
Yes,
Lagos?
yes, I'm okay with it. Yes, I'm okay with it.
Okay. So now let's move on. So now we have done for look at the beautiful thing, gentlemen. Do you know if I want to do for another mix, let's say a mix of let's say I want to do for why Excel is beautiful. Let's say I want to do for C25. C25 here will be what?
1.5.3.
So the total here will now be what? And that's all I need to change. Here will now be 5.5. As soon as I change this thing, everything in this calculation will change. And even the price. That's why you need to build, you need to go with this.
Why can't we format
80,000.
Engineer Oshe,
Sir.
Let's format the 5. Before now, I didn't know that is the summation of 1 + 2 + 4 that's 7. So I didn't know that is a summation. So, but if we put it as an equation, one can be able to get it.
So what do you want me to do now?
That if you format it as equals to 1 + 1.5 + 3, anybody that picked the exam.
Okay.
Yeah,
that's true. That means I'll remove my mix design here.
Yes.
I will now say equal to. Yeah. Now that's a good observation. No.
That's
I need
5.5 and put it there.
5.5.
No.
C3.
If I must do it. No, I can do it. See, this is what I'll do. Equal to. Equal to
1 plus
this. No, is there even?
That's what I did.
Okay, good.
Yeah.
This.
Yes.
Plus this.
Excellent.
Yes. Enter.
So here will now be. So that's the only time changing. So it's only the mix station I need to change.
Okay.
We're still back. The beautiful thing about Excel is that you still get 80,000 naira. Look at now. What I play smart. Why did I play smart? I said minimum rates without profit and the maximum rate. So anything between 61,000 and 73,000 is good. Are we together?
So can I ask a question?
Yeah, go ahead.
What I just noticed, mostly contractors now, we normally embed in our tax inside.
Embed what?
Tax. We call it tax.
Okay, VAT.
No, VAT usually is at the end. But
okay, what do you call it, sir?
Withholding tax is usually included here.
So what you could do, sir, is simply come here and put it 25%. That's all I can say. Which is 5% extra. Yeah. Yes. So here 5.
Yes.
That's it. That's just
thank you.
Sir, observation, sir, and question. I just checked the rate, the state rate, and I observed that the rate with 35% overhead, levies, and profit for indigenous contractors is 57,972.38 kobo, and that is quite low for the present day Nigeria. And then the rate for major contractors with 45% overhead, levies, and yes, Julius Berger and co. We're having 62,266 naira, 63 kobo. So obviously,
OJ, what you ask yourself, when did Lagos State government, when did they do that rate? That's just what you ask yourself.
2017.
So where are we now?
2022. So how I should prorate it, or I don't know.
No, this is more current. This is more realistic.
Yes, I know.
I think even then it was a very nice rate. As 2007.
Even then it was a nice rate. It was a wonderful rate.
Yes.
Yes.
Yes, because the profit margin is such that the contractors can really appreciate the job and really do a good job.
So
but
let's put at 5,
right
let's
now,
put 0.35 here now. Case closed, it's 2,000. In fact, we should start from here, sir. So it's a 2,000. That your rate now should be. Or something like that. Are we together?
Yes.
Yes, we are together.
What? Yeah, change it. Which one?
Any question again?
Yeah.
So, I mean, this is just for learning purpose. So you can go ahead and play around with it. But one thing I just noticed now that we've done something good is that we're able to come here and say equal to this plus this plus this. And that is cool. So everything remains. So for C15, 4 bags of cement, and the price 51,000. So that's the only change I'm going to do so that I can save this. So I'll save. So we are done with any question on concrete, please. I'm ending concrete. We're going to reinforcement now. No question.
I just have a contribution.
Okay.
Yes. What we have done now is we have calculated the components of cement, sand, and aggregates that we are going to use in making our concrete.
Yes.
But this assumes strength. The strength that we have assumed now, we are not sure that this one will give us the value until we have done the crushing.
Trial mix.
Trial mix. When you do the trial mix with this mix now, and it's giving you the strength, then you can be sure that you can go ahead with it. Sometimes when you do the working on the table like this, and you go ahead and cast like that, it doesn't give you the strength.
Okay. Engineer, I appreciate that, but you know, we have a diverse group here. Not everybody here will be a civil engineer, and I doubt whether they will really understand what you're talking about. So that's more like a practical thing, and I agree with you completely. There should be trial mix, there should be everything that will follow. But I know from experience, if you can get your people, your mixers to get this, you'll be within 90% accurate. That's all I can say. So the idea of this, listen, once again, is for you to have an idea how these things are done. Because your knowledge of one thing will lead you to knowledge of another thing. We didn't do roads. If you follow the parameter for road or parameter for other things, you will get the same thing. Are you with me, sir? So let's quickly, because of want of time, remember we must finish this in today. This module 2 today. So let's go to the third next thing, reinforcement. So the reinforcement, the first thing you do about reinforcement is to have a knowledge of how to get each size of iron, how different densities. And the density of every iron is d squared over 162. These parameters are in open domain. Can you just go online and say unit weight of iron? It will bring you these parameters. But if you are the lazy type like me, you just do d squared over 162 for every size, where d is the diameter of the iron. So the diameter of the iron times 2 will give you the unit weight, because the same principle that we just discussed is something you're going to follow. The difference is this. Stay with me now. Density is mass over volume. But if I now say the unit length, it means I'm keeping the diameter constant. There's something we need to understand. Let me bring in the whiteboard. See, this universal formula holds true. Density will always be what? Mass what? Over what?
Volume.
Now, volume is area times what?
Height or thickness.
No, let me borrow length. Area times what? Length. Okay.
Times depth. Okay.
Whatever. It depends on, iron comes in length. Okay. So this area is more like saying the cross section. It's like saying the cross section. So why I'm saying this is that instead of putting volume here now, if I put length here now, this thing would change. Instead of calling it density now, I'll call it unit weight. Mass already weight or unit mass. I don't know how it looks like. So when I now say unit weight or unit mass, it means I'm keeping one of the parameters constant. Stay with me. I want to achieve something. Now it means this one will now be, because I now say units. So if I make this the unit, or let me say unit density, sorry. If I say unit density,
Goes to what?
I'm now referring to mass over length. Okay, the whole story is this. The whole story is this. The whole story is that when I get the unit weight of a element multiplied by the length, it will give me the mass, because mass is density multiplied by what?
Volume.
Volume.
Equals to,
yeah. Unit weight is now or unit mass will now be what?
Density.
Unit density.
Times
what?
Unit volume.
No, sir. Length. Well, let me not confuse us, but I know what I'm arriving at. What I'm trying to arrive at is, look at this place. You see now, this is 8 mm. The unit weight is what? 0.39. It means that for 1 meter length, per meter length of it, what is the weight? This. Per meter length of 10 mm is what? This. Per meter length of 12 mm is this. So if I now come now and say that I calculated and I got 700 meter length of iron, the answer will just simply be equal to, sorry. If I now say I'm calculating for 700 meters, the answer here, what is now the total length of iron? I will simply say the total length of iron will just simply be this multiplied by their respective unit weights. Watch me now. Watch me now. Watch me. So it means that if I do my bending schedule and the total length of 10 mm I got, assuming you did them in a straight line, is 700 mm. It simply means this is total length. So if I now want to do like a layman, I will simply divide each of these by 12 meters length. So it means I need 23 length of this. This is the length I need for each of these things. Okay, that is number one. That is the layman. So I'm trying to lay the foundation for what we're going to do. I'm trying to lay the foundation for what we're going to do. So let me quickly delete it again. So if you now come here now, this number is just how many pieces you have in the market. For 8 mm, 1 ton of it is 210 units. 10 mm is 133 units, gives you 1 ton. For 12 mm, 92 lengths gives you 1 ton. 16 mm, 52 lengths gives you 1 ton. Why I'm taking my time to emphasize this is that I've observed over time that client will ask you for how many lengths. If you say, client, let us buy 2 tons, most times the work does not require up to 2 tons. Are you with me? So what I want us to do now, I want us to go through our work. Can we go through some of these this unit weights? Can we quickly go through them online, just like we did? Can you corroborate this unit weight? Then we'll move forward. I want to give you 2 minutes. Go to Google now, just check unit weight of concrete. And then for each of them, try to do the density square over 162. Make sure you are getting this, so that this will become something that will be in your system, that you don't need to Google for this again. Yes. And then also confirm whether this is length that gives this. Because I know this. Only these 2 is the one I don't know, because you hardly use them. But this one, I know it's 52 units. This one, I know it's 123. So can we do that in just 2 minutes? And that will also serve as a small break for us. We'll resume by 5 p.m. Thank you. So I'll quickly pause this. He said you should use 1 ton. And if you prorata this thing now, it simply means for 1 cubic meter, you should use 100 kilogram. For plain concrete, like mass concrete. If you are now going for highly structural elements, you can increase it to 150 kg or 1.5 ton. If it is for a non-structural member, the code permits you to use even between 0.5 to 1 ton. So for let me just put it this way. So for 1 cubic meter, 1 meter cube, the code permits you to use between 0.75, watch me, for non-structural elements, as in the barest minimum you can go is 5 kg. But the optimal, the nominal is 100 kg. Then the upscale, the optimized value, assuming you are doing something for like concrete piers or pie cap, okay, or bridge abutments. You know, those ones have gone beyond, or like slab for bridges. Those ones are, so you can use between 150. So for 1 cubic meter, you can use 150 kg to 200. But I doubt if there's anybody that uses more than 200. For what, even if you are doing a subsea construction. Now, this is for nominal design, if you don't want to stress yourself. So your job is to calculate your volume of concrete. You translate it to tonnage of reinforcement. You now go back to the table I showed you. You now know how many pieces makes up 1 ton for Y8, for Y10, for Y12, for Y16. So knowledge of that unit weight is the most important parameters. And that's why I told us to go online and try to search it online. You'll see that it's all over online. But I also gave us the formula on how to get it. And that formula is diameter square over 162.
162.
Diameter square over 162. So you don't need to stress, so whatever it is. So if I'm using Y12, I will simply tell my client to get me, assuming I'm using Y12, I'll ask him to get me 92 lengths. Assuming this thing, I got 0.5 ton. If I got 0.5 ton, you know what I will do. I will now multiply 0.5. Yeah, assuming I now do my analysis and I got 0.5 ton. 0.5 ton means I'm casting about 5 cubic meter of a slab work for a two-story building. I want you to begin to see where I'm going to. Okay, so that means that is what I will use. If you did not do that, and that is the simplest way, I will recommend to you to do it. Because the other way to do it is so cumbersome. If you're not a strictly structural engineer, you will never get it done. And that way is by way of bar bending schedule. bar bending schedule. So bar bending schedule simply is a table that will tell you the number of iron you need based on the configuration. So let's assume now we draw our elements. 5 meter slab by 3 meters. So let's say this side is 5 meters. And here is what? 3 meters. So you know that for you to do a bending schedule, you must know how to interpret a structural drawing. That's why I'm strongly recommend you use this nominal method to do this thing. What you only need to do is to use your worst case scenario. After getting your value, you can multiply by 1.5 or by 1.1 or by 1.05, as in 5% for waste, for cutting, or 10%, and then another 10% for risk. So you multiply your value by 1.2. Most engineers don't do that. After getting your value for anything, assuming instead of asking for 50 length of iron, you ask for 60 lengths. What you have simply done is to multiply by 1.2. That means you have increased your risk factor by, let's say, by 20%. And those 20% are aggregated risk. 5% for cutting, 5% for stealing, if there's anything like that, 10% for fluctuation in market price, and what have you. But if you want to do it, to get it in a detailed way, it means if this is a slab, 5 meter by 10 meter, 3 meter, then that means the engineer will now draw the iron like this and draw this one like this. He will now come here and label this one. For this, after the instructional design, he got this spacing to be 200 by 200, 200 spacing. It means here will be like 25 by 12. So this means 25 inches of Y12. The bar mark is say 0.1. And the spacing of the reinforcement, 200. What is the location? It will be B2 because it's running parallel. No. Yeah, no, this will be B2. B2.
Should be 15.
Are you sure? 200. Yeah, 15, sorry. It's the other one that is 25. Thank you, sir. Okay, then he will now label this one. Remember, this is the difficult method of getting this thing. But I can tell you, if you use the nominal method with experience, somebody will spend 1 week doing this thing. You, as an experienced engineer, you get your value by just getting the volume of your concrete and applying the nominal reinforcement. I've done a bill for a client in 24 hours for a 4-story building in 2016. I'm not bluffing. The client himself, the consultant, was surprised. How did he come up about with a bill for a 4-story building, though the concrete work only, concrete carcass, in 24 hours? Yes, I did it. Because as soon as I computed my floor, number of columns, each column, how many concrete will it carry? I multiplied by number of columns. My cubic meter for all the columns came out. The number of beams, what is the value for one beam? So it's a 450 by 230 beam. Most of them are 6 meters, end to end, based on the slab bay. As soon as I got it, I was able to get, let's say, 2,000 cubic meter of concrete for first floor, second floor, third floor, and that is it. And then for reinforcement, bam. For formwork area measurements, calculate the number of, which we're going to do now. I came up with the bill. And of course, I must confess, I got the job. But it's only for, he bought the materials anyway, just for supervision and consultancy. So now for this one now, it will be 25, right? Y12, the bar mark will be 0.02. And the center, 150 or 175 or whatever, but let me be lazy. Let me put 200 again. And it will be B1, because some will say bottom one or whatever, B1, because the main reinforcement. So If I'm now to do the bar bending schedule of this one, once I see this value now, I will now draw a table that looks like this. But for me to steal a template, I'll go online because I know I can drag the table. But I always tell our engineers, nobody invents the wheel. And don't expect me to invent the wheel. It doesn't make sense. I'll look for the wheel somebody has invented. I'll modify it and it become my own wheel. So now, if I go to Google, for instance, I'll say charts of bar bending schedule. Then when it opens, I'll go to images. There are 1 in a million of them. 1 in a million of them. Millions of them. Okay? But they are all the same thing. They simply will show you the number of the ion, where it occurs, like this one, look at it. The type of ion, because there you can see different ions in one building. The shape of the ion, the length of the ion, the number. So the length of one and the number in that member. If you now multiply the length by the number, it will give you the total length. Then multiply by the unit weight, it will give you this weight. Then this shape we are drawing here is to guide you. This shape will help you come about this. For instance, the bend here is 0.19, the bend here is 0.16, and the clear length is 750. So 750 plus the right bend plus the left bend. So if I go to a different one, it's still the same thing. So let me go to a one that will be a little bit different from these two. So
we're not seeing your screen.
Yeah, oh, you're not seeing my screen. Oh, okay, just go to Google, sir. Just go to your Chrome. Type chart of bar bending schedule. So look at this chart now. The serial number is number 1. The bar mark, okay? The number of bars, the number of members, the length of this bar, the length now is this plus the bend. Total length is 5.23. 5.23 multiplied by number of bar, then multiply by the number of places it occur, will now give you the total length. Then, based on what we said, density is mass over volume. Therefore, mass is now density over volume, or unit density over unit volume. That is where you now see 0.888, which is the unit weight of 12 mm. So this thing is now in tonnage, in kg, or in tonnage. So this is total tonnage you need. So this thing is under this column because it's under 12 mm. This one is 10 mm. This one is 10 mm, and so on and so forth. So this is example of a bar bending schedule. So for you to calculate reinforcement, you need to prepare a schedule like this. So there are hundreds and millions of them. You can use any format. The idea of showing you this thing is just for us to choose one particular format that we can work with. And if you really want to kill it, after here, you can come here and say XLS, meaning that Google should give me only the Excel files. So Google will now give me the Excels. Okay, like look at this one. I said bar schedule for Excel 94. I'm just trying to buttress how you can use this. Okay, look at it. This is an Excel sheet. This is an Excel sheet. So let's look at what it's going to give us. Okay. So look at the Excel. So there are millions of them online. There are millions of them online. So you can just go there, download the one that looks best for you. So this one looks good. So I can come here and put my company name. Oh, this guy locked his own. Who cares? Who told him I need it? So I can just go and look for the person who didn't lock his own, and I'll prepare a bar benefit. Some people are so selfish. Why will they lock it? Okay, let me just create my own. Okay, so to create this thing now, I'll simply come here. I'll go to my Excel and create one. Yeah? I'll just create for want of time. No. See, if I search more, I can get a selfless guy.
You see,
like me, I don't. This information I'm giving you, I've given it out to my people in the group. No need locking it. I mean, why would I lock it? I mean, how?
I think we can do this.
Maybe we can do it, but time we don't. I want to. I said I don't invent the wheel. I don't want to invent one. I want to steal one. I want to take one, a beautiful one, one somebody has prepared. This can lose good. Or will he be magnanimous to release it for me? Okay, he said download. If I want to download now, I'm going to download virus. So now, I will. We can do one. We can actually do one, but for want of time. Okay, let's just do for this our man here. Okay, why am I killing myself like this? Okay, I think I have the team to do one. Let's do one ourselves. Are you sure one is not? One should be here already. I mean, I'm supposed to have built one. Okay, they won. So SN. Okay.
That's your screen.
Okay, SN. SN. The next thing after SN will be what? After SN will be
Bar mark.
bar mark. That's following that. You can ignore bar mark. After bar mark, you can put member. Can we put member? So I can say this one applying. I'll come here. I'll say slab. Are you with me?
Yep.
Bar mark will be 01. Serial number will be 1 to 10, of course. Then here will be shape, right? And out of shape, I'll increase it. So I can draw the shape. Okay. Here will now be length.
Length.
The next one will be number.
Total length. Okay,
total number. Then total number. Then the last one will be weight or mass. Okay. Good. So we have only 2 members here. Let's assume we have only 2 members. And all of them all appear in the slab. Okay. Right. The other one, the bar mark is 01. If I didn't format this cell as test, this thing will never give me that. So I will have to format it and say test. It never give me 01. So I'll come here and say test. I don't know why it's giving me the error as if I don't know what I'm doing. So for the shape, now I can't remember how to bring ruler here. Even long I use it, but there's a place to bring ruler. Shape. Insert shape. Right?
Go to view, you see ruler.
View.
Check.
Yes, it's on view.
No, it's not a ruler I'm talking about. There's this place that you bring draw toolbar. They draw toolbar.
Okay.
There's a place you bring in the draw toolbar. There's a place to bring draw toolbar. Okay, so I can come here, draw or shape, insert shape. It's not even here. Okay.
We have pictures, shapes under insert.
Yeah, under insert. Yeah, but it's not, my own is not showing. Okay, clipboard.
It's hiding. You have to look for the drop down.
Go to illustration.
If really I'm interested.
Illustration.
No. Okay, illustration.
You see, yes, you will see shape there.
Wait, wonder what? Wonder what menu?
No,
illustration.
Illustration.
Okay. Thank you. So, but you know, this banding schedule is not done in Excel anyway. It's done in AutoCAD, okay? Yeah. It's done in AutoCAD. It's done with AutoCAD. In fact, the latest software is now for design will give you the banding schedule automatically. So it will look something like this. And this will not work here. I'm sorry about that. So here, I should be able to put in a value, edit tests. That was 5 meters, yeah? Okay, let's not go far, okay? Let's say, I think you guys understand what I mean. So if here is 5 meters, and the bend is 100 meter, 100 meter, the length will now be 200.
What is?
Okay. The other one is 200. Are you with me? See, this is 5 meter. They bend 2. 3 meter. They bend. Okay.
How much do you?
So this 5 meter, the number is 25.
15. No,
the number here is what? 15.
Yeah.
So
okay.
what will be the total length now?
To be the length times the number.
Thank you. And that would be 5,200 times 15. And that will give you 78,000. Okay. And this one will be 25 times 3200. At this age, are you there? 80,000.
Da kansa da shi ai na mata ne. Da kan kuwa kuta ne.
So this
Why
is
not
it.
use formulas there now? It's not possible for us to use formulas. Is equal to E2 times F2 now.
So 12 mm. 12 mm is 0.888 unit weight. Am I right?
Yes.
Or let me simply write the formula. We were supposed to even put bar type, right?
Yes, bar type, yeah.
So let me put the formula here. Formula will be equal to what? This raised to power 2 divided by what?
162.
Yeah. Therefore, the weight, this is the length, this is the unit weight. So what is the mass? Equal to this times this. Am I right?
Yes.
Total. I need to be fixed. Total will now be what? Auto sum. So if I divide it by 1,000 to bring it to kg, so I need 140 tons. No, sorry, 140 kg, because this is in millimeter, right? Are you with me? This is in millimeter. So I can as well change it to 5.2. So take note. So this is in kg. So I need 140 kg, no? Yeah, it's about that, which is 0.14 tons, yeah? Let me just do everything in kg.
Hello.
Yes, sir. I'm here.
Okay.
Any question? I don't want us to digest this thing. Are we following? Are we following?
Yes, we are following.
Yes, sir.
So this is 0.14 ton. Am I right?
Yes.
Okay. So if we do it nominally the other way around, this is a plain object. What is the volume of this concrete? What's the volume again? The volume is about 2.25. If you multiply it by the lowest value of 0.75, what will it give us? Are you seeing a similarity? Are you seeing something? I'm getting 168, and here I'm getting 140. Does it make sense?
Yes.
Okay. So for you to do your enforcement, you have to, once you get to this place, the underlying factor is just for you to know the unit weight. Once you know the unit weight, You multiply by the correspondence and then you get it in kg, divided by 1,000, you get it in tons. That's all. But if you want to do it very fast, just get the volume of the reinforcement of the element and then use your minimum values. So the knowledge you need here is knowledge of this. Then in terms of interpretation, you need the knowledge of this. So that when you want to know how many pieces they will buy, after getting this, you get a total weight. You get the total weight. You get the total weight. So once you get the total weight, you now multiply as expected. So any question on this, please? Any question on reinforcements? Can you comfortably do reinforcement? So if I'm doing a building, I will estimate the number of columns, pad, the shape of the pad times the depth. It will give me the value for one column. I multiply by 20 columns or 30 columns. It will give me the volume of concrete. With that volume of concrete, I will now use 100 kg per kilogram per cubic meter, or 75 kilogram per cubic meter, since it's a foundation element. And maybe it's only one floor. But when it's going towards 4, 5, 6 floors, 10 floors, then I'll use 100 kg per cubic meter. If it's not something that's being done in a very bad soil or is a raft foundation, then I can scale it up to say 150 or 120. But the standard is in BS code. But as a layman, if you're a layman or want to work with laymen, you use the minimum number. You use your nominal reinforcements. Okay, this one will carry nominal reinforcements. 75 kg for every cubic meter, or 100 kg for every cubic meter. Any questions? So let's move to formwork. Let's move to formwork. Let's move to the formwork. So for formwork, the first thing you do for formwork is you ask yourself, what is the typical thing expected in the formwork? So let's take a look at the formwork. A typical formwork. You can go online, for instance. You can go online and say, formwork for slab, for instance. You go to images. A typical formwork. For concrete. So, what are the elements? There are about 5 elements. Okay, this is for a foundation. So you have to identify the elements. Okay, let me use this one now.
Are you sharing your screen, sir?
Just go online. Go online, look at the typical formwork. This is a typical formwork. And this is a well-done formwork, okay? You look at these polines. They are in two sets. The first set and the second set. Then you have the sheets. You have the props. You have the poline, you have the struts, you have the sheet, you have the props. So 4 elements. So your job is to say, for 1 square meter, how many props, meter length of props, how many polines, how many sheets, and how many props you need. So once you get that, you can build your rates. So I'm trying to see if there's other things. Okay, look at it, the same thing. Well done. This is a well done formwork. So there are many of them. So I don't know which one. They're just there. There are just many of them. Well done. Okay. If it's something that's being done on the floor, like a foundation, you know you don't need props. You don't even need a bottom. So all you need to do estimate is the sides. You don't even need formwork details. Okay, this is it. This is really what I'm looking for. So this is a typical formwork. For a slab or wall. Now there's no difference between a formwork for a slab and a wall. A wall is basically a vertical slab. A vertical slab is basically a vertical slab. So you can see there are two elements. The one directly on top of the sheeting or sheet is called the joist. The joist. Then the one supporting the sheeting, supporting the joist, is called the stringers. And then the one holding it, which could be bamboo or any other element, is called the shoring. So there are 4 elements. So all you need to do is to now look at these 4 elements and know the cost per meter length. What is the cost per meter length? To do that in Excel, you go to the next sheet. So here, we are using marine plywood. So for plywood, we all know, we all use plywood. It comes in, which is the sheet now. The first element is sheet. The sheet. I combined the joist and the stringer. This is another term to use. But let me rename it here. I combined both the joist and the stringer. Some will call it the poline. Then this one is the shoring. Call it props, but it's shore. Here, so let's assume we are using plywood. Our job is to get what is 1 unit, 1 square meter. Then later you can measure your member in terms of their perimeter, in terms of their shape, in terms of their bottom and everything, and you get the other values. So, but for now, we are looking at plywood. The size of plywood is 2.88, and the number of plywood is 1. So for 2.88, that is the size because it comes in 1.2 by 2.4. So if you multiply 2.4 by 1.2, the square area will be 2.88. And then for the joist and stringer, we are looking at using 2x3 wood. And based on our calculation, it is 2 per meter length. If time will permit me, I will show you how we got about 2. For instance, this is a slab of 3 meter by 5 meter. Don't mind the distance. So the sheet is automatically 15 square meter. You are buying 15 square meter of sheet. Okay, the sheet is automatically 15 square meter. There's no two way. But if you now put it, if it's a slab, the sides, the thickness of the slab, remember, is 150 mm or 0.15 meters. So if this is 3 meters, 3 meters times 0.15 will give you about 1 meter. This one, 1 meter, 1 meter, 1 meter. So this thing will be around 19 or 20 meters. 4 meters for the sides. So the total will be 19. If you now put a wood here, put here. This is 5 meters. The wood comes in 3 meters. So let's assume 2.5. I've done this calculation several, but this is also where experience counts. This is about 2 wood. So if I take out a shape of 1 square meter, 1 meter by 1 meter here. That's what we're talking about. If I take out 1 meter here, how many of these will fall into that. Let me not go into details because we have only 15 minutes to spend in this class. But from the experience I've gotten, you will need about between 2 to 3 woods, meter length, to achieve that. Okay, so the number we need here is about 2 pieces, 2 lengths of wood will do 1 square meter. Okay, so look, 2 lengths of it will do a square meter. Then for bamboo, 2 bamboo for every 1 square meter. 1 square meter means 1 meter by 1 meter. And you know that these shorings are done in 60 by 60. After every 60 meters, you put another element. That's why this carpenter will also ask you, what spacing should we use? So let's not go into those details because the template is already here. So this bamboo will be two pieces. Then the price of plywood in the market is about 15,000. Okay. So what is the cost per square meter? So per square meter of it will be 15 divided by this. So this is the price. Then 2 by 3 wood is 400 naira in the market. It's 400 naira in the market. So 2 pieces of it will give you 800 naira. The bamboo is 700, which some of these prices might be wrong, but just take it, but we are bringing the rate. 2 pieces of it will give you 1,400. If you now sum it up, it will give you 7,618 naira. But we now said we expect to reuse it twice per one. So that brings the cost. You divide it by 2. You divide this total cost by 2 to give you 3,000 something. This is without profits. Without profit. So if you don't add profit will give you this. Okay, which is D10 multiplied by G7. Okay, that will give you this. So I added my profit based on the total. And if you now add up this plus this, it will give you labor 15%, profit 10%. The profit means 760 naira per use. I'm quoting for square meter of formwork. Then my labor, I assume 15% for each square meter, 15% of my total. So if you add this and this, you end up at 5,708. 5,708. So this is now the quotation for 2-time use. But if I'm using it 3 times, I will now divide this by 3. I12. So here, if we are to use it 3 times, which is not, I won't advise you, don't ever do it. In fact, I'm supposed to delete it because it's not possible to use plywood 3 times. For every you reuse of plywood, you lose about 30 to 20 to 30% of it. So we assume the other 30% you put in will make you use it again and again. But then, if you look at the average usage, it's twice. If you say once, you might be pure economical with the truth. So 2 times is enough. So the average use of formwork, we should quote for formwork, is about 5,700. So the only thing that didn't show us in this class is how we came about these 4 elements. How you estimate, but I've shown us this one. If you're using bamboo, if you're using sheets, plywood comes in 3 square meters. Okay, so 3 square meter, and each shape comes in 15,000 or 12,000. So if you divide it, you know the cost. Then this one, 2 length of it will give you this. This one 2, another 2. Then shoring is 2. Why is it 2 per meter length? Because when you draw 1 meter by 1 meter here, this one will hold the other one. This 2 is holding this 2 meter because this center to center spacing here is about 600. Center to center spacing here is about 600. So 2 bamboo for 1 square meter we do. So if you now know the total area you are doing the formwork, you divide it by 2. That will give you number of bamboo you need, considering the fact that some bamboo will take you 2 times. So it depends on the kind of bamboo you're buying. So, but that one is not here. Now, if you are using steel formwork, if you are to use steel formwork, the prices will change. The price of a sheet of steel is at 20,000 naira. The shape is the same. It's about 2.4 by 1.2. Then you buy angle iron. Those iron now with angle iron. And angle iron is about 2,000 naira. You need 2 of it. For each square meter, you need 2 angle iron, and that will be 4,000. Props in the market is about 8,000 per one for a height of 4 meters. So 2 of it is about 16,000. Then the nuts and the bolts you use to tighten them is about 500. So the total length is what? 27,000. But you'll agree with me that for steel, you can use it, you can reuse it up to 5 times. So if you are to use it up to 5 times, we divide this value by 5. It will give us this. We now add our profits, add our other things. It will be giving us around 10,000. So you can quote 10,000 for steel formwork and 5,000 for plywood and wooden formwork. For wooden formwork. So now this template is there for you. Your job is now to reject it, because depending on the elements you're using, you can increase this to 3. You can also reduce it by 1. Assuming you are doing 2-side formwork, maybe a retaining wall. If you are doing a retaining wall, these things will change to 2. This one will change to 2. Then this one might not be up to 2 anymore. Or it could also be 2 again. Please, gentlemen, take note of that, and ladies. If you are doing 2-side, let's say retaining wall, then you need to change this. For the wood, if it is a 2-side formwork, I will know that this thing becomes automatically number 2, because formwork will be on 2 sides. And once I do, all my values should reflect. It doesn't? It should. If it doesn't, then I need to reformat it. Okay. If it changes here, it becomes 30,000. So it means I need to put in the formula. These 2 has to be somewhere. These 2 has to be somewhere, so that I can multiply this by 2. Are you with me? I'll come here. If it is for 2, I'll multiply by 2 here. I don't know how to do that, but it's doable. But you understand what I mean? So when I multiply all the elements that I'll call by 2, this thing will change. So my quotation for reinforced for steel formwork will likely change. Okay, somebody said angle iron cannot work for steel formwork. It will collapse. Okay. 4 mm angle iron will work, sir. 2-inch angle iron, 4 mm gauge will work. There's a light gauge, there's a thick gauge. I believe it will work, but it's subject to something else. But I know that 2,000 naira, sorry, the cost is no longer 2,000 naira. That's what I'm talking about. Maybe you have a point. The cost is about 4,000 naira now. Yeah, it's about 4,000 naira now. The thick one, 4 mm. So it's about 12,000 naira for the steel. But the good thing is that reuse is much. I put 5 times reuse here. It could be more than that. And that's why you don't use steel formwork until you are doing a very large work that you need to reuse it up to 5 times, 4 or 5 times. If not, the cost will be so exorbitant. So that is that. So for the formwork.
Observation.
Okay.
Observation, sir.
Yes.
For the sheet steel and the plywood.
Yes.
We're having 2.88 for the square meter.
Yes.
But on the templates, on the per square meter, don't you think we're supposed to divide the by 2.88 to get the square meter cost?
That's what we did.
Because
That's what we did.
Okay, can you double click on the box?
I've done that.
Let me see.
Look at my formula bar. Look at the formula bar. Look at the formula bar.
Oh, okay, okay.
Yeah, I can also double click. Yeah, it depends on what the way you understand Excel. Just look at the formula bar. Okay. Somebody said that angle iron will work for drain wall, but not for suspended slab. Well, engineer, the idea is you know what, I don't know what you intend to use. If you compute those Perry wood, I don't know the price in the market, but it will not be beyond 4,000, I believe. It might be, but just whatever you're using here, sir, as your joist and stringer, just put it here. Just put the cost here. For we here in Nigeria, we're using 2x3 or 2x4. So let me change it. I can change it to 2x4. This price will now change to 600. But you have the templates. You can change anything as you deem fit. It's still around 5,000 for 2 times reuse. You know, I know that 5 years ago we used to quote 3.5, 4,000, 2.5 self. But those ones are like for drain work, small drain work. Okay, and the reusability is up to 3 times. So you can still fall within 3,000 or 3.5. Any other question? So let me save this and close this work and resend it. So I don't know if I should, I've closed it. So let me just go to our address bar and resend it to our chat box. Though it's practically the same thing, because all you need to do now is to look at it, 25th of March, updated, 5:56 p.m. Okay, so go to the chat box and download it. Any other question? Yesterday we overshot. Today I don't plan to do that. So I'll let today's weekend so the people can go and rest. The video will be sent to us. The video for the other one have been sent. Simply go to YouTube and get it. Let me send it again.
Your name on the YouTube is what?
Oh, good. My name is Inhueze U. But yesterday we said search with the name or the title of the course. In fact, all our courses, search the name, you get it, sir. But my name is if you now click on the email, you can now go and subscribe. So that every video I upload will come to you. Of course, that's how it works.
So I didn't get you, sir.
I'm putting my name on this thing. On the chat box. And the YouTube for yesterday is there. So if you go to the YouTube of yesterday, you now click on the name, on my name, it will take you to the home page. Or you just simply subscribe.
That yesterday material, do you have a PDF copy of it?
Which one?
That yesterday.
I've sent it. It's in the link I sent. It's there. Every material is your right to have them.
Yeah, what I can't get it to all this. What I want is if you can send it to my mail.
Yeah, I will send it, but at the same time, I'm using this opportunity to introduce everybody to cloud, to start using cloud. So I think some Germans taught me that when they came for one training, they asked us to open Gmail. And what they did was to upload it inside Gmail, and everybody will go and download it. So since that time, I said I will adopt their method. Well, each time I remember them, I remember they taught me that. So I also want you to remember me with something.
Yes,
so I'm finding it difficult to download from the YouTube. How do I go about it?
No, you need a YouTube downloader. You don't need to download, sir. Just watch it from YouTube, sir.
All right.
Yes.
Okay, that's one. Then maybe, I don't know if you have sent anything to our emails that were provided.
Not yet, sir. It is your certificate. I wish every sir. Would you sorry, most is what we do is cloud, and that's why the first day in this class.
I have cloud. You need to send.
You download. You open Gmail, and when I send you this link, sir, once you click on it, it automatically enter your shared folder. Try it. It
I've tried it. It's not working. I can't find anything in my.
That is what. The simple way to do this is just send the link to via our
mail.
Yes. Yeah, so we can, from there can get to the
exactly.
You understand? You can get to the cloud and get it.
Yes.
Yeah, exactly.
Doing it in this chat box, it will not work. Just send it all this link to our mail, then we'll be able to get it.
Okay, let me suggest also, because I think I did a training on NSC platform just last month, right? What we did, all the participants, we created a WhatsApp group where all the training were packed, and every responses or whatever information we need to pass, the chat, the group chat, we all shared that same information. That would be easier for us if all of us will provide our phone numbers. And a group chat on WhatsApp. Every information, both the training that we have had now, we can put them there. Then we download and either transfer to our.
Okay, I'm going to create a WhatsApp group tonight.
That would be perfect.
Okay, I'll do that.
Thank you, sir.
Thank you so much.
Okay.
All right.
I'll do that now.
Okay.
I'll do that. We'll create a WhatsApp group. In fact, it's long overdue.
Yes.
The other thing you are referring to, I think I was also part of it, so I can relate with that. So
all right.
We'll create it. We'll create it.
Okay.
We'll create it. But just know that
you still go for training.
Sorry?
You still go for training.
Why would you not go for training?
Yes, sir. I do, sir. I keep improving myself.
It's very good.
So
yes, now.